In this particular video, I'm going to discuss the quadratic formula and show you why it works. So let's first look at the quadratic equation. It has the form ax squared plus bx plus c is equal to 0. A cannot be 0 because if a is 0, all you got is a linear equation. Bx plus c is equal to 0, and that's fairly easy to solve. And then you have the quadratic formula there. Okay, and we'll go look at that in more detail later on. But first of all, I want to remind you that when you're solving quadratic equations, generally they give you three methods. They ask you to solve it by factoring, they ask you to solve it by the method of completing the square, or they ask you to use the quadratic formula. Okay, so in the factoring method, you're basically using the zero product property, which tells you that if you multiply two or more numbers out and you get 0, at least one of those numbers has to be 0. Okay, so if x times y, and it could be 2 or it could be more, so x times y times z is equal to 0, then either the x or the y or the z have to be 0, or they could all be 0. Okay, so we use that idea and tell you, okay, make one side 0. If you get to solve by factoring, make one side 0, and then factor the other side. In this case, we get x squared minus x minus 6 by rewriting this. Factor that into x minus 3, x plus 2. So that tells me that either x minus 3 has to be 0, or x plus 2 has to be 0, or they both have to be 0. So we set each equal to 0. X minus 3 equal to 0. You solve that and we get x equal to 3. In the same way, we set x plus 2 equal to 0 and we get x can also be negative 2. So we get 3 and negative 2 is the solutions. Okay. The next method is the method of completing the square. So let's look at what a perfect square trinomial is. A perfect square trinomial is one that's the square of a binomial. So as an example, let's look at 9 x squared plus 12x plus 4 equal to 0. Well, I don't want it equal to 0 here. I'm just going to factor this. So here I'm just looking at the trinomial. So this is an example of a perfect square trinomial. Again, a perfect square trinomial is simply one that's equal to the square of a binomial. So in this particular case, if you factor this out, this is going to equal to 3x plus 2 squared. Okay. Perfect square trinomial equals the square of a binomial. You can easily check that by multiplying out the right side. Now in particular, I want to focus on those trinomials where the coefficient of the squared term is a 1. So let's look at x squared plus 2x plus 1. If you try to factor this out, you're going to get x plus 1 times x plus 1. So this is x equal to x plus 1 quantity squared. Okay. Another example. X squared plus 10x plus 25. If you factor this out, you get x plus 5 times x plus 5. So we can write this as the square of the binomial x plus 5. Okay, now let me use symbols so I can make my point here. Let's say we write x squared plus bx plus b squared over 4. Okay, so this is a trinomial, and the coefficients are, for the x squared we have a 1, for the x we have a b, so the coefficient of x squared is 1, the coefficient of x is b, and the constant term b squared over 4. Well, if you try to factor this out, again it's going to be the square of a binomial, so it's a perfect square. This is going to be the square of x plus so it's the square of x plus b over 2. Okay, so the point I'm trying to make here then is that if you have a trinomial and the coefficient of the squared term x squared is 1, then if it's a perfect square trinomial, the third term is going to be the square of half the coefficient of the x. So notice in the first one here, x squared plus 2x plus 1, half of 2 is 1, squared you get 1. The second one, half of 10 is 5, squared you get 25. And in the last one, half of b is b over 2, squared you get b squared over 4. Okay, and the quadratic formula is basically derived using that particular property. Okay, so let's cancel this out here. So solving this by completing the square, and again what we want to wind up with is we want a square on the left side and a constant on the right side. So if you have something like x squared is equal to 25, see, it's very easy to solve. You just take the square root of both sides, plus and minus, and you get x can be plus or minus 5. Okay, now let's suppose we have something like x minus 1 quantity squared. Okay, so see, the left side now is actually a trinomial if you square it out, but it's a perfect square trinomial. See, I have the square of a binomial, but in the right side, if you have a number, say like in this case 7, all I got to do is take the square root of both sides, plus or minus. So I would get x minus 1 should equal to plus or minus the square root of 7. And obviously for quadratic equations the degree is 2, so you expect to have at most 2 solutions. Okay, you could have repeated solutions, you could have real solutions, you could have imaginary solutions, but at most you're going to have 2. Then you solve here for x, and you get x can be 1 plus or minus the square root of 7. Okay, so now let's cancel this. So the objective then in completing the square is you want to come up with something that looks like this. Because then all you got to do is take the square root of both sides using the plus or the minus. So you clear this. So the one I just solved, okay, the x squared minus x is equal to 6. Then if I want to make, I keep the 6 on the right side in this case, but if I want to make the left side a perfect square, I take 1/2 of the coefficient of the x, which is -1. So 1/2 of -1 is minus 1/2. So it's but then you square it, and you get 1/4. Okay, so in order to make that left side a perfect square trinomial, I have to add 1/4 to that, to the left side, which is x squared minus x. So adding the 1/4 is where this comes from. But in order to keep this legal or balanced, I have to add the 1/4 to the other side. Okay, so 6 added to the 1/4, basic addition, 25 over 4. Okay, and then this then, as a result of adding that 1/4, satisfies the property of perfect square trinomial, because it's just the third term, that the coefficient of the lead term, x squared, is 1, and the third term is the square of half the middle term. So this should factor into x minus 1/2, x minus 1/2 squared. Okay, so now this is what we want right there. Now we just take the square root of both sides, plus or minus, so x minus 1/2 is equal to plus or minus 5/2. And then that would mean then that x then would equal to 1/2 plus or minus 5/2. And then we just add these. So the 1/2 okay, so the 1/2 here, and say the 5/2 is 6/2, that's the 3, and then 1/2 minus the 5/2 is a minus 4 over 2, which is the negative 2. Okay, so we get the same thing we got with the factoring. And of course, if you use the quadratic formula, then your a value is the coefficient of the squared term. That would be 1. The b would be -1, and remember the c is on the left side, so if I bring the 6 over, that becomes a negative, so c is equal to -6. Then you plug those numbers into the formula, and of course you're going to get the same answer. But the main thing here is how this formula is derived. Okay, so here's what we're doing then. We're taking the equation ax squared plus bx plus c, except in this case we're leaving this as constants here. We're not putting actual numbers, a, b, and c. So we're going to treat the a, b, and c just like they were numbers, like in this equation here, 1, -1, and -6. Okay. So what I do then is I take the c over to the other side, and I get a -c. And then the objective then is to complete the square, make this a perfect square trinomial. Okay, so remember in the examples that I went over, the coefficient of the x squared is equal to 1, so that's why we get the next step. So what I'm doing here in this next step is factoring out an a. So I take the a out, this becomes just x squared. This b then has to become b over a, because when I multiply, I have to get the same thing back. So a times b over a is the bx. Okay, there you have it. Now I have to add something right here to complete the square. So what do I have to add? I have to add the square of half the middle term. Okay, so half of b over a is b over 2a, and then I square that. So that's going to give me b squared over 4a squared. So this means then that if I add that to the expression, the x squared plus b over ax, that will complete the square right here. Okay. But remember, whatever I add to one side, I have to add it to the other side, otherwise it's not legal. Okay, so let me just clear this for now. So clear this. So now we know what we have to add inside the parentheses. Okay, so here it is right there. B squared over 4a squared. So this middle part right here, or this expression in the parentheses, then now becomes a perfect square trinomial, because the third term, see the coefficient of the x squared, and I'm looking inside the parentheses, so this is a 1 on the x squared, and then the third term is the square of half the b over a. Okay, so that should be a perfect square. Okay, so now we have to add the same thing to the other side. Okay, so you're saying, well, why do I have b squared over 4a? I mean, if I'm adding b squared over 4a squared, but remember, what's in the parentheses is multiplied by a. So if you multiply that third term by a, okay, if you multiply that third term by a, one of the a's cancels, so this becomes a 4a. So I'm actually just adding b squared over 4a to the left side. So that's why I have b squared over 4a. Okay, and then combine this. So the denominator is 4a, so I've got to multiply this one by 4a. Bottom and the top by 4a, so this becomes a 4a here. And then I just rearranged it. I put the minus 4ac second, so it matches the actual formula. So I get b squared minus 4ac. b squared minus 4ac. Okay, and then of course this then factored into x plus b over 2a quantity squared, and then here just divided through by a, or if you want, I multiply both sides by 1 over a. Okay, so that cancels this here, and then over here on this side, when I multiply by 1 over a, that becomes a 4a squared. Okay, so I got this far. Okay, so now I have it where I have a quantity squared, and remember, this is just a number. Even though I got a bunch of letters there, those are just numbers. So that's going to give me one number. Clear this. Okay, so in the next step, then I take the square root of both sides, plus or minus. Okay, so the left side I just get x plus b over a, and then over here I get the plus or minus, and I get this. Okay, and then remember the 4a squared is a perfect square, so if I take the square root of the numerator over the square root of the denominator to simplify this radical, then this just gives me this. Okay, instead of the radical here, I just got 2a. Then I just bring the b over 2a over to the other side. That becomes a minus b over 2a, and because I have the same denominator, I can put it all as 1. So x is equal to minus b plus or minus the square root of b squared minus 4ac over 2a. And this is how the quadratic formula is derived. Okay. And obviously, if you had a choice, obviously the number one method you want to use is factoring. If the quadratic factors, that's the easiest way, quickest way to do it. And then the second option, if you have a choice, your instructor might tell you to do it one way. Okay. But if you had a choice, then if it doesn't factor, the preferred method would be the quadratic formula instead of going through all the procedure for the method of completing the square. So if we actually solve the original problem, okay, so the formula is x, x is equal to minus b, but b is negative 1, so that's a minus a negative 1 becomes a 1, plus or minus the square root of, and then it's b squared, but b squared is negative 1, so you square negative 1, you get 1, minus 4 a times a, but a is 1, times c, but c is negative 6, and at the bottom it would be 2 times a is 1. Okay, so what do we have then? We have 1, so we have 1 on top plus or minus the square root of, and then negative 6 times negative 4 is 24, and 1, that's 25, over 2. We know the square root of 25 is 5, so it's 1 and 5 is 6 divided by 2, gives me a 3. And then 1 minus 5 is negative 4 divided by 2 is negative 2. So we get the same answers. Okay. So again, the main purpose of this video is just to show you how the quadratic formula is derived. And again, there's many formulas that you encounter, or change of base formula when it comes to logarithms that you know how to use it. Maybe you don't know how it's derived. Well, this is just an example of a formula and how it is derived. Hope it makes sense, and we'll see you in the next video. Thanks for watching.